Hello Science 8 students, and welcome to your first science flipped lesson on graphing. So let's get started right now. So why do we create graphs? Well, there's four basic reasons, so let's just outline those right now. They all make pretty much common sense. So here we go. Here are the big ideas with making graphs. It allows you to visually represent collected data. It allows the reader to see trends in that data. It allows one to make predictions. And it's an awesome mathematical tool. So let's get started on making some graphs. The first thing we're going to need is what's known as data. And that's going to be the thing that we're going to graph. So let's get some data up here. Okay, so here's our data. It's distance versus time. And so what we have to do is we have to figure out how we're actually going to take this data that's in a chart or in a data table and put it onto a graph. So here's our data. We're going to just put it over here for a second, and now let's get some graph paper. Here's our graph paper, and there's our data. So now what we have to do is just figure out where we're going to put our data. So we have data on distance, we have data on time, but we're not really sure what goes on the x-axis, what goes on the y-axis, and that all depends upon which variables we're calling the independent and the dependent. So I found a great website that's going to help you with that. So let's take a look. So here's the website, and you can kind of see some of the information here, but it's probably much better if you just go to the website right here at the very top. You type that in your browser, or you can just Google mathsxscience.com, scientific method variables, and you'll get this page. But you can already see right here at the very top, there's terms independent variable, dependent variable, and this is critical for us in terms of what variable is going to go on which axis. So make sure you go to the website and read this whole section on experimental variables. Okay, you're back from the web page. We still have our data, we still have our graph, so let's start with a graph title. Every graph needs to have a title, so let's do that right now. So based on the data, a good title for this graph would be distance versus time. For our class, when you title a graph, make sure you also include the units, so distance in meters and times in seconds. The next thing you want to do is draw in the axes, so I'll do that real quick. You can follow along. So there's the x-axis. Let's label that time in seconds. Just like that. Now let's put in our dependent variable of distance on the y-axis. So there's the axis, and now let's put our label on. So now I have both the axes labeled correctly. So I have the dependent variable on the y-axis. So that's distance, and I have the independent variable on the x-axis, which is time. So now that I have this all set up, we have to come up with what's known as a scale, which really means how much are each of these boxes here going to represent in the y direction, and how much will they represent in the x direction. And there's a pretty easy trick on doing that, so let's go and take a look. So here's a short little blurb on setting the scale. So pause the video and read through this, and then we'll go back to our graph to actually use these techniques to figure out our scale. Now that you have more information on scales, count the number of boxes on the time axis. Pause the video while you do that. You should have come up with 15 boxes. So you have 15 boxes, and you have 5 points of data here. So you're going to take your 15 boxes, and you're going to divide by 5 seconds. So then each second is going to be represented by 3 boxes. So let's put that on the axes right now. So as you can see on the x-axis, I have time. It's labeled, it's got seconds, and every 3 boxes represents 1 second. Now let's use that same technique for figuring out how we're going to do our distance. Okay, so my range of data. Alright, so now we have to do the same thing with our distance on the graph here, and if you count, you're going to pause the video and count the boxes. and then you're going to do the division. Let's see if we both end up at the same spot. So pause the video now. Okay, I have data that is 25 meters, and you should count 19 boxes. Okay, when you do this, you're going to end up like with 1.3 meters per box. That's not going to fit, so what we're going to have to do is we're going to have to go 2 meters per box. So that means every line, every box over here represents 2 meters, and if you just count it out, that will definitely fit. I'm not going to draw, or I'm not going to label every box 2 meters because that's just going to get messy, so I'm probably going to label maybe every other box. So this is what it looks like. I moved the distance. If you look up here, I just moved the distance label way up here so it wasn't in our way, so we could actually see it. So there we go. That's what our graph is looks like with our axes all labeled. The title there, the scale there. So let's go on and plot some points. Okay, so let's begin plotting our points. We have a 0, 0, so we're going to put that right there. Now at 1 second, we need to be at 5 meters. It's kind of like right there. 2 seconds, we need to be at 10 meters. About there. At 3 seconds, we need to be about 15. At 4 seconds, we need to be at 20. And at 5 seconds, we need to be at 25. So our data kind of looks like that. So now once you have the points plotted, you have to determine whether or not you're going to do a best fit line or a best fit curve. So does your plotted data look like a line, or does it look like a curve? So you decide, pause the video, and then start it once you have your decision. Well, hopefully you thought it looked like a line. So now we have our relationship between distance versus time expressed using a graph. Let's go to some new examples. Okay, so here's our second set of data. We're going to practice with this. So the first thing I want you to do is label the axes and come up with a title. So pause the video, do that on your paper next to you, and then start the video again. So your drawing should look something like that. So now let's come up with our scales. So again, try that technique that we learned earlier in this video. So you can see the time fit on really easy. So now try the heights. Here's the scale for the plant height. So we're just left with plotting points now. So again, pause the video and plot your points and then start it when you're done. Okay, here are the plotted points. Now this doesn't really look like a line. It looks to me like it's probably a little bit more of a curve. So let's sketch that in. Something like this. Okay, so there's your graph for the table 1 of experimental data, plant growth versus time. Let's do one more example. Okay, here's our last graph, and by far this is the most difficult one, just in terms of determining which one's your dependent and independent variable. Remember, your independent variable is what causes the change in the dependent. So for this particular problem, the independent variable is going to be the pH of water. So that's your independent variable, and that's going to go on the X. This is your dependent variable, and it's going to go on the Y. Okay, so I'm just going to give you all the answers in one shot, so pause the video and make your graph. Okay, when you get to this spot, this is kind of what your data should look like. It's kind of weird, but this is going to be kind of like a curve you might see in math. So let's see if I can put this together for you. Kind of goes up and then goes like that. Okay, so that's your shape of your graph there. So this kind of concludes our graphing flip lesson. You can review it as many times as you want. When you come in class tomorrow, we'll have some assignments that will be based upon you completing this work. So make sure you understand it, because right when you come into class, we're going to get started.